Hello students, today we will start with kinetic molecular theory of gases. This theory provides a general explanation for the properties of all gases at molecular level. It has some postulates. Let's discuss them one by one. The first postulate is all the molecules of a gas are identical. The molecules of different gases are different. This is nothing but if we are talking about a sample of gas, it means a container which contains CO2. Obviously, we know that gases are made up of very small molecules. So, according to this first postulate, the molecules of a particular sample of a gas are identical. Identical means they have same structure, same mass. Means if we are talking about a sample of oxygen, all the molecules of oxygen gas will be identical. They have same shape and same molecular mass and other dimensions. They all will be identical. While the molecules of different gases are different. That means if we talk about different samples, that means one is of carbon dioxide and other is of oxygen. The molecules of oxygen are all identical. The molecules of carbon dioxide are also identical, but the molecules of oxygen are different from the molecules of carbon dioxide. They differ by shape, mass and other physical dimensions. So this was the first statement, that all the molecules of a gas are identical. Means all the samples of a particular gas will have same type of molecules. They all will be identical in terms of mass and volume and shape. All the molecules of a gas are identical and the molecules of different gases are different. Now the second statement is all the molecules are rigid and perfectly elastic spheres of very small shape. The kinetic molecular theory assumes that the shape of gaseous molecules is spherical. They are spherical in shape, very small, spherical and rigid and perfectly elastic. Rigid and elastic means they are hard, means their shape does not change. They are rigid and they are elastic. Means if they collide with something, then they don't deform their shape, they just regain their shape back. That is elasticity. Elasticity is the property of a matter by which it retains its original shape. So the molecules of gases are rigid and elastic spheres of very small size. They are perfectly elastic and rigid. The third is the actual volume of the molecules is negligible as compared to the total volume of gas. What does this mean? You all must be knowing that volume of a gas sample is equal to the volume of container. This is the basic property of gas, that gas does not have fixed volume. It occupies the container in which it is filled. That means the volume of a particular gas sample is equal to the volume of container. Why this is so? Why is the volume of gas equal to the volume of container? This is explained by this statement. Actually, the size of a molecule of gas is so small that it can be neglected when we talk about the whole volume. The difference between the two molecules is very large as compared to the shape, as compared to the size. Size of a particular molecule of gas is so small that it can be neglected, and the volume of gas becomes equal to the volume of container. The actual volume of molecule is negligible as compared to the total volume of gas. Okay. Another is, the next statement is the molecules are in state of random motion. That means a molecule of gas always move in any direction, no particular direction. This is called random motion. A zigzag motion or random motion, they always keep on moving in random directions, no particular direction, just they are in continuous motion in any direction. This is called random motion, and this is a very important property of gas. Gas particles move continuously, randomly in any direction. Now, while a particular molecule of gas is moving in random direction, definitely it will collide with another molecule and it will collide with the wall of container also. So this is the statement. The molecules are in state of random motion. They always move. They always keep on moving in random directions. During this, they collide with each other. The two different molecules or more different molecules which are moving randomly in different direction, they will collide with each other sometime, and also with the wall of container. This collision is perfectly elastic. Means while two molecules collide with each other or they collide with the wall of container, energy remains fixed. Means there is no transfer of energy, no gain of energy or no loss of energy during collisions. The collisions are perfectly elastic, and when they collide either with each other or with the wall of container, they change their direction. That means, let's say it is a wall, the molecule comes, collides with the wall, and after collision it changes its direction. It may move in this direction, this direction or this direction in any one, but it will change its direction after collision. Okay, let's take another example. Let's say a molecule of gas, this is moving in random direction, this, then it collides with the wall of container. After this, it will change its direction. It will collide with another particle, another molecule of gas, and it will again change the direction. Again, it will collide with the wall of container. This time again, it will change its direction. Every time a molecule of gas collides with either wall of container or with another molecule of gas, it changes its direction. And also, these collisions are perfectly elastic. Again, when a molecule collides with the wall of container, it exerts some pressure on it. If a molecule will collide with the wall of container, definitely it will exert some force on the wall, and this is nothing but the pressure of gas. A pressure of gas is the force exerted by the molecules of gases which are moving in random direction on the wall of container due to their collision. All the molecules collide with wall. This, and every molecule, when it collides with the wall of container, exerts some pressure on the wall, and the total force exerted by the collision of all the molecules is the total pressure of gas. So this was the story of collision. That means the molecules collide in two ways. Either it collides with another molecule or with the wall of container. When it collides with another molecule, it changes its direction. Again, when it's collided with wall of container, it changes its direction. But while colliding with the wall of container, it exerts some pressure on the wall, which is known as pressure of the gas. Okay. The molecules are in state of random motion. During this, they collide with each other and wall of container. And collisions are perfectly elastic. Perfectly elastic means there is neither gain or nor loss of energy during collision. The collisions are perfectly elastic. And next statement is, there is no attraction or repulsion between the molecules. That means there is no attraction or repulsion between the two molecules, and they move independently to each other in any direction. They just interact with each other at the time of collision only. Other than that, the time of collision, they do not attract each other. If we talk about solids, the particles of solid attract each other. This particular attraction or intermolecular attraction is reduced in case of liquids, but in the case of gas, there is no intermolecular attraction between the particles or molecules of gas. They move independently to each other. There is no attraction or repulsion between the molecules of gas. Further, the average kinetic energy of the molecule is directly proportional to the absolute temperature. Now, what is this? When we heat, actually, that molecules of gas are in random motion always. That means, now, motion means kinetic energy. When the molecules of gas are always moving, that means they have some kinetic energy and they do not have potential energy. Molecules of gas do not have potential energy because they are always in motion, and the particle which is under motion contains, yes, kinetic energy. Now, kinetic energy will increase with increasing temperature. Whenever we heat the molecule, whenever we heat a gas, the molecules absorb energy from the heat and they start moving with a faster speed. That means the velocity of the molecules or the motion of the molecules increases with increasing temperature. Whenever the heat will be provided to the system, that means to the gas, the molecules will start moving with faster speed, and that's why the gas expands on heating, because the particle starts moving with a greater speed whenever we heat them. That means the kinetic energy of the particles increases with increasing temperature in case of gas, obviously. Okay. So the kinetic energy of molecule is directly proportional to the absolute temperature. These were the postulates of kinetic molecular theory. Let's revise them once again. All the molecules of gas are identical. The molecules of different gases are different. That means a particular sample of a gas will contain same type of molecules. That means all the molecules of oxygen are similar, identical in shape and mass and volume and other properties, while they differ with the molecules of carbon dioxide or any other gas. That means the particles of particular gas are all identical and they differ with the particles of another gas. The molecules are rigid and perfectly elastic sphere with very small size. They all are spherical, very rigid and perfectly elastic. The actual volume of the molecule is negligible as compared to the total volume of gas. Total volume of gas is equal to, yes, the volume of container. And why this is so? This is because the volume occupied by molecules is very, very, very small as compared to the total volume, so that it can be neglected. The molecules are in state of random motion. They always move. The molecules of gas are always move in random direction, in no particular direction, but they just move in zigzag direction. And during this, they collide with each other and walls of container. During the collision, they change their direction of motion, and these collisions are perfectly elastic, means that neither they gain energy nor they lose energy during these collisions. There is no attraction or repulsion between the molecules. The interaction between the molecules of gas is zero. There is no attraction or repulsion between the molecules except the time of collision. The average kinetic energy of molecule is directly proportional to the temperature. As we discussed, when we increase the temperature, molecules get energy and move with a faster speed. That means their kinetic energy increases. And again, another thing, the potential energy of the molecules of gas is zero because they are never in rest. Potential energy is the energy because of position, while the molecules of gas are always in random motion. That means they always have kinetic energy, they do not have potential energy. That was. So, on the basis of this kinetic molecular theory of gases, an equation, a mathematical equation was derived, which is known as the kinetic gas equation, in which PV is equal to 1 by 3 m n v square. Now, P is pressure and V is volume. M is the mass of a molecule, that is molar mass of a particular molecule. N is the number of molecules presenting the volume V, and U is the root mean square velocity, or we can in general say the velocity of a gas molecule. So this equation is known as kinetic gas equation, and this is a mathematical form derived from the kinetic molecular theory. The concept of kinetic molecular theory are very basic, and they provide a theoretical background for all the gases law like Charles law, Boyle's law, Avogadro law, and Dalton's law of partial pressure. These all can be explained or have a background of kinetic molecular theory. So I hope the theory is clear to you. Thank you.